In this lesson, we're going to learn about the trapezoid and isosceles trapezoids and their properties. So the first thing is focusing on a trapezoid, and by definition, a trapezoid is a quadrilateral with at least one pair of parallel sides. Those parallel sides are called the bases, and the non-parallel sides are the legs. So the non-parallel sides would be the legs. So if you look at this picture here, the parallel sides, remember you can mark parallel with the arrows. Those are labeled base 1 and base 2, and then the legs are the two sides that are not parallel to each other. So with trapezoids, there's not really a whole lot you can do with them other than know your definition and know the parallel that you do have a pair of parallel bases, or at least one pair of parallel sides, which are called the bases. And the other thing that you should know is the median, how to find the median. So the median of a trapezoid is similar to the mid-segment of a triangle. If you remember, a mid-segment of a triangle looks like this, where you connect to the midpoints. And a mid-segment of a triangle is always half the length of the opposite side, and it's parallel to the opposite side. For a trapezoid, the median is serving as that same type of segment. Sometimes it's called the mid-segment. But it has to connect to the midpoints. So M is a midpoint and N is a midpoint, meaning those parts are equal. But one thing to know here is that the median is going to be parallel. So all of these are parallel. It's parallel to the bases. And also the median is going to be equal to 1/2 the sum of the bases. So instead of just saying 1/2 the base, well, there's two bases, so you have to do 1/2 the sum of the bases. So there's your formula for it. So that's how the length relates, and then also it's parallel, just like in the triangle. Now, this is a mid-segment in a triangle versus a median in a triangle connects from the vertex to the midpoint of the opposite side. So this is a median connecting from the vertex to the midpoint. So just be aware of the differences. So in a trapezoid, we call that median or mid-segment the same. We use those words interchangeably, but for triangles, there's a difference. So just be aware. So that's like the only property really that you can use with trapezoids, other than the fact that the bases are parallel. Then we look at isosceles trapezoids, which means, just like an isosceles triangle, two equal sides, two equal base angles. An isosceles trapezoid, so let me actually sketch a picture of that since we're talking about triangles as well. So an isosceles triangle has two equal sides, two equal base angles. When we look at an isosceles trapezoid, the definition says it's a trapezoid with congruent base angles. But if you notice, again, there's two bases, so really there's two sets of congruent angles. So angle D and angle C and angle A and angle B are your base angles, so both pairs of those are congruent. And then also there's a couple additional properties right here. One is the fact that since this is an isosceles trapezoid, these legs have to be congruent, so basically the non-parallel sides are going to be congruent to each other. And then additionally, the diagonals are congruent. So a diagonal in this, well, first of all, the diagonals are not drawn. So if you were to draw in the diagonals, that means from A to C, that diagonal is congruent to diagonal DB. So in my picture here, let me just add that. That would mean DB is congruent to CA. So from here, using these different definitions and properties, let's look at answering these questions. So never assume that you have an isosceles triangle or isosceles trapezoid unless it states so in the problem. So when I look at this first example, it does not say it's an isosceles trapezoid. My picture looks like those are congruent legs, but it doesn't specify, so I can't make that assumption. So since this is a trapezoid, that means I have at least one pair of parallel sides or parallel bases. So in this case, the parallel bases are AB and DC. So if I want to find the measure of each angle, well, I'm thinking parallel lines being cut by a transversal. So if you look, I have my two parallel lines. Here's my transversal. These two angles are actually going to be supplementary because they're same side interior angles. So that means if I want to find that other base angle here at angle D, I'm going to do 180 minus 78, and that's going to give me 102. The same thing is going to go for the other side here. So again, I have my parallel lines, I have my transversal. These are both same side interior angles, so they're going to add to 180. So that means I'm going to do 180 minus the 132, and I get 48. So that will always be the case for trapezoids, even if they, if it's isosceles, well then these base angles are all going to be congruent. But if the trapezoid is not isosceles, you still have the parallel bases, so that means you still have these same side supplementary angles that are formed. So I'm just going to write that down. So parallel lines implied supplementary same side interior angles. So that's how I made that conclusion. So that'll always be true for these. So then example 2 talks about this trapezoid. Again, can't assume it's isosceles, with a mid-segment. So we have a mid-segment. So that means we're going to be using our formula that the mid-segment or the median, remember they're interchangeable for trapezoids, is equal to 1/2 the sum of base 1 plus base 2. So that means my mid-segment is MN. That is going to equal 1/2 the sum of these two bases. So here's my bases, so add them up. So 4x minus 7 plus 6x plus 5. So combine like terms here. So 19 equals 1/2. In parentheses, I have 10x minus 2. And then it's really up to you at this stage if you want to distribute that 1/2 through, or if you want to multiply both sides by 2 to clear out that fraction. Either way, just make sure that if you multiply by 2, you only do 2 times the 1/2. You don't need to actually distribute the 2 since you haven't distributed the 1/2. So that would work. I'm looking at both 10 and 2 and seeing that they are divisible by 2, so I'm just going to distribute it, not even worry about the fraction. So 19 equals 5x minus 1. Bring the 1 over. Divide by 5. So we get x equals 4. So again, that's just using the mid-segment rule and knowing that property. So if we go to the next page here, on this page, we are going to look at how to prove that a quadrilateral is a trapezoid. So there's 2 things that you could do. One being you have to prove that the quadrilateral is a trapezoid, which means you have to show it has 1 pair of parallel sides. And then if you're trying to prove that it's an isosceles trapezoid, then you have to either show that the trapezoid has, so first of all, prove it's a trapezoid, and then show that it has congruent base angles. That would make it isosceles, which is going to be tough to do on a graph because you can't really prove congruent angles on a graph unless they're right angles. So the other method, which is going to be your common method on a graph, is going to be to show that you have a trapezoid with congruent diagonals. So I'm going to make a note of that, and I'm going to put a star by that one. So let's go ahead and look at this example. So we're going to start with graphing our quadrilateral. So we have 1, -4. Make sure you're labeling your points here. So we have 10, -4. And we 9 up 2. So we have 2, 2. So here's my trapezoid that I want to prove is isosceles. So the first thing I need to do is show that it's a trapezoid. So to show that it's a trapezoid, our first step is going to be show that we have 1 pair of parallel sides. So I'm going to look at this and say, well, the 2 sides that appear to look parallel are DC and AB. So let's start with that. So we're going to start with showing it's a trapezoid. We're going to use slope formula to show parallel. So we have our change in y's over our change in x's. So the slope of DC we're going to plug in. So DC we're going to be doing 2 minus 2 on top over 2 minus 9 on the bottom. So it's going to be 0 over -7. So this is going to be 0. And then we look at AB. So we have -4 minus -4, and then 10 minus 1. So this is going to end up being 0 on top over 9, so that'll end up being 0. So this tells me that DC is parallel to AB because they have the same slope. So therefore I can conclude that I have a trapezoid. So I can conclude from this that quad ABCD is a trapezoid because it has one pair of parallel sides. So there's your first step. Your second step is going to be to prove that this is an isosceles trapezoid. So once you know it's a trapezoid, because it has to have at least one pair of parallel sides, which it does, in order to prove it's an isosceles trapezoid, I'm going to use number 2 here. So I'm going to show that it's a trapezoid with congruent diagonals. So that means I need to find the length of AC. So I'm going to use distance formula. So I'm going to just actually write AC. So AC, the length between those 2 points, will be the distance formula. So I'm going from 9 minus 1 when I subtract the x's, and then 2 minus -4. So I'm going to plug in. So I end up with 8 squared plus 6 squared. So this is going to give me 64 plus 36. So I'm getting the square root of 100, which is going to equal 10. So the length of the one diagonal is 10. I'm going to do the same thing for the other diagonal, and it should be equal. So DB, I'm going to subtract the x's. So 2 minus 10 squared plus 2 minus -4 squared. I'm going to just write AC in front of that so it's not confusing. So I get -8 squared plus 6 squared. So again, this is going to simplify to 64 plus 36. So that means DB will be the square root of 100, which will give me 10. So therefore, the diagonals are the same. So now I can write my conclusion stating that quad ABCD is an isosceles trapezoid because it's a trapezoid with congruent diagonals. So again, remember, you have to show that the diagonals are congruent. Do not show that the side lengths are congruent, the 2 legs, DA and CB, because that isn't enough information to prove that this is an isosceles trapezoid and not a parallelogram. And like I said, we'll talk more about that in class. But for right now, just know that you have to get to the trapezoid and then prove that the diagonals are congruent in order for it to be isosceles. So get your key ideas down from the video, and we will talk more about trapezoids in class.